Okay guys, I made this video because it looks like you have problems to understand the the, the exam the quiz we did the other day about adding vectors and how is the scalar going. So everything is in the chapter 3 and the one that you should read before we did a quiz, at least read, but of course you should study and well, here they explain quite well what is a vector and what is a scalar. Well, anyway, a vector, as you already know, is how we measure some quantities like velocity or, or like like the distance. It's something that besides a magnitude, we need to know which direction it's going. So a vector holds those things. It's a it's the combination of a magnitude and a direction. And a scalar is just a magnitude. Like for example, the temperature. You need to know the direction of the temperature. You need to know what is the temperature of maybe the water. So this kind of things. Okay. Now, how do you present a vector graphically? Well, usually you have they draw arrows with it, right? And you use a Cartesian plane with a x and the y-axis. And for example, in here you have this. This is a vector. Why we know this is a vector? Because first of all, it's bold, and also it has an arrow on it. That's one of the ways of the notation of the vectors. Okay. So in here you have one vector that is called in the x-axis, and another one, the y-axis here, and here is just adding vectors graphically. So for adding vector graphically, where is it? Where is it? Here it is. You just put like for example to compute this one, which is b1 by plus b2 plus b3. You just put one after another, and then you join them. Okay. v1 is here, then here you put v2, here you put v3, and from the initial point of v1 to the ending point of v3 you just draw the vr. Okay, this is in graphical mode. It's important, but that's not what I asked in the quiz with the other day. Okay, so how do you this is how do you multiply some vectors, and here now this is the main thing. Like one of the ways to represent the vector on paper without doing it in graphical mode is by components. Okay, we know a vector has a magnitude and direction, and usually we represent it in the x and the y-axis in the xy plane. So one of the easier way to do it is using the components. You have it here, like you decompose the vector. This is what is called. You have a vector with a certain angle in the xy plane, and it is easier if you do it. If you represent it with components. This we already know how to do this. We did it thousands of times in the separator motion, like bx. In this they represent bx with a vector, but actually it should be we usually do it with a scalar. Like we know it's in the bx is in the x-axis, so we don't need to know what is the direction. We need to know what is the magnitude. Okay, it's actually what is says in here, like the scalar components, the bx and by usually is what we want. We assume that these guys we assume the direction of these guys because we assume that we already decompose this vector in these two components in the xy axis. Now how you compute them from one to another, we already know, we saw it thousands of times, but if you need to refresh your mind, here you have a nice example. You have b which is have a angle theta with the positive x-axis, which is the way you always represent the angles. And okay, so what is Vx? So Vx you have in here, Vx is equal to b, which is the magnitude of this one, times the cosine of theta. Well, we did this many times. This is just trigonometry, I guess. Uh, by now you should know trigonometry. If not, well, you should need to learn just a little for this. Okay. What is the this is the mere definition of sine. Okay. You see here, opposite sides divided by the hypotenuse. So if here you consider them scalars, then it's what you have in here. You can consider them scalars because we know the directions. You know that when I mean the directions, because they are in the x-y axis, so we know. Now the tangent of this guy, of theta, is sine divided by cosine, which is the same as vi divided by vx, by, sorry, by divided by vx. And the relationship of the modulus of all these vectors, the scalars, are the Pythagorean theorem, right? Okay. Now, how do you add vectors? Well, there's as we saw it in the graphical mode, but we talk about components, which is usually the way to add. The reason why we decompose all these vectors in Vx and Vy, so in the x and y axis, because adding by components is way easier than adding graphically or with the other method, which is setting the magnitude and the angle. Okay, so now we want to imagine that we want to compute this. Vr is equal to the v1 plus v2, all of them are vectors. So what we do is we decompose these guys, v1 and v2, in each one in vx and vy. Okay, we can do that by multiplying the v times the cosine for the vx and times the sine for the vy, and then we add all of them component by component. Like, for example, we get the x component of this Vrx is equal to v1x plus v2x, and then for the y-axis the same. Now this is how you give it by components. If you wanna give it by module and angle, you use this. Then the whole module of Vx of the Vr, it would be this squared plus this square root of that. And if you wanna compute the angle, is the antitangent, the tangent minus 1 of this over this, the y over the x, and that's it. You can check this example, and that's how it's solved. Now imagine that, like in the quiz, we want to compute Vr that is equal to 2 times v1 minus 3 times v2. So how can we do it? Well, first you have to multiply the vector by a scalar, and by doing that you just multiply each component by the scalar. Okay, so in here I say 2 times, if I remember correctly, 2 times v1, so you have to multiply here v1x 2 times v1x and 2 times v1i, and here minus 3 times v2, so it would be minus 3 times v2x minus 3 times v2y, and you're going to get the same thing. Okay, so that's everything. I think everything you need to know about adding vectors. guys, this is just a mere explanation. I hope you understand it. Just the book is in here. Each of you have a book, so you can read it. You can reread it again. You can watch the video again if you like my voice. Whatever. Just guys, you need to be proactive. You need to learn this, okay? And learn and understand it. This is very basic. If you don't know this, it's very hard to do what is next, which is what is this projectile motion. Okay? Here, check always these boxes. They give you hints of how to solve problems. So when you have to add vectors, you have to follow these steps. This is going to be methodical. It's good. This is what you need. You need a method to solve these things. It will help you to understand first. Once you master this, you don't need any shortcut. You don't need anything. Okay. Now the other example, the second question of the quiz, it was a pure projectile motion. It was just exactly like this. Okay. Like I think I saw a problem here. But again, for projectile motion, you have this, which I already told you in class many times what you have to do, but still follow it. Okay. This is just exactly like the first part of the first part of the second exercise of the quiz. Like instead of a car is a motorcycle, but it's the same. The guy needs to reach 90 meters before it gets to the ground. So this is how they do it. You can read it. Basically, computes how long does it take for this guy to get from here to here. Bearing in mind there is an acceleration, and use that time to compute the speed to go from here, the horizontal speed to go from here to here. Now, y and x, they are independent. One doesn't affect the other. We see this many times. We saw it in this test. So you shouldn't have any problem with that. If you have any problem, please read this and understand it, and you should do it. Okay. If you have any more problems, even if once you read it, you try to understand it and it's not working, just tell me in class. We can talk about it. Okay. The second part of the second exercise of the quiz, it was like this one. Exactly the same. Now, if you remember, it was a car that now it has a ramp, and the ramp has an angle. So instead of going straight forward, it has an angle and it's going like that. So you have to compute how long does it take to the car, well in this case to a ball, but in the quiz it was a car, to go first up, because it has a vertical velocity in the y-axis. So the velocity has a component in the y-axis which it didn't have before. So it's going up, and then again down we have the gravity again. And you have to compute how long does it take to reach the ground, how much time, and then use that time to make sure that this speed is enough to reach this point. Okay, you have it here. Okay, so read these examples, go through it, understand it, and we will see. So good luck, and next time as you write this, it has to be crystal clear. Okay. Bye.